Well, we've identified the equipment. We've talked about the O&M, and that you'll have the full-blown O&M supplied on hand for you guys to reference in the future. We talked about long-term storage, basically draining the tank. Any kind of damage that's done to the equipment itself can be located in your O&M on the drawings, and then contact our company, Sanitary. All the numbers and information are in the O&M to contact us. And as we say, we can get the stuff right out to you if in the event that anything happens like that. I think what we're going to do at this time, we're going to conclude our class training, and we're going to go down to the actual East Basin aeration grid, and we're going to take a look at the system itself face to face. I can identify the components and what to look for preventative maintenance, and we'll take it from there. Okay.
Do you know what the amounts would be roughly that you have in the drawings or whatever? Just says.
This is with the orifice. They actually, you must have a. Okay, yeah, this is going to be a orifice that actually will plug into here, and there's you probably have some different applications for this diffuser, and it's requiring that you have an orifice hole to distribute the air better, and that's why they do that.
Brian, there's two applications on this, in the grid system as well as in the influent channel.
Okay, so more than likely you're going to have orifices in one and not in the other, which is very different, but that's what it is. Okay. I didn't catch that. Thank you. Yeah, the orifice, actually what it does is it just plugs into the end of here, pushes right in, and that just creates an orifice for the airflow, so equal distribution throughout. And it's also used as a balancing tool too. I mean, with air and diffusers, the whole thing is a balance act. Everything should be on its own elevation, same elevation. Different places in the plant, something might be a little bit lower, so that's when you would go with an orifice. And that's probably the case with the grid tanks compared to the channel. Does it come off a common air manifold?
It's separate air systems. There's a blower for the channel on the primary settling tanks, and a separate set of blowers at the grid facility.
Okay, you got the aerosols downstairs for the channel.
Yes.
Yeah, and then you got the other ones. Yeah. Okay. So you guys want to take a walk? We'll head down to the tank and take a look. Okay, here we are. We're at the east end grid channel, and as we talked about in the class, we're going to take a look at the system down in the basin itself, and I'm going to give a description of exactly what we have in the basement, and then we'll just kind of do a couple short briefs of what to look for preventative maintenance, and certain little things that we can do as far as determining that we're getting equal distribution throughout the manifold. As you see in the basin down here, okay, starting from the top of the tank, this is our common air feed main that's coming in, and it's connected by a follower flange. If you follow the drop down the tank, this is what we consider a drop leg. We'll connect to what we call a fixed header. This fixed header is the 4-inch piece of stainless at the bottom that goes from left to right. Attached on the bottom of that piece of pipe is what we call the gussets and the actual distribution to go out to the D24 diffusers that's shown in the classroom. As you can see, there's 5 diffusers located at the bottom, and these were all installed at a set elevation throughout the grid. As you can see here, we have 4 different manifolds and all on the same air main. So if the valves are all open, we want to make sure that we have equal distribution through the whole channel. Okay. As you can see on the end of the manifold itself, on both ends, you can see a cap with a bolt in the center. This is what we had talked about in the classroom. This is what we call a removable end cap. In the event when you take down the basins to do preventative maintenance, this is one of the particular caps that you can take off and actually flush the manifold itself, and in addition, cleaning out the diffuser elements themselves. The application that locates this manifold onto this certain elevation, as we can see, is we have angle supports that are put into the wall, which is a mechanical wedge anchor. Everything that you see located in the tank itself is a 304 stainless steel. These particular manifolds and headers are what we call a removable header. As you can see at the top of the drop itself, by the follower flange, there's a locating key, okay? This would be used so you can clamp onto the manifold itself and pull it up right out of the cradle from the metal struts down at the bottom of the tank. This is in the event that, say, if you were under full operation right now and you're looking at the top of the surface of the tank itself, and you found out that in a certain area of the tank it seems to be very dead with air. There's not a good distribution of air. That's an indication that you have some kind of a fouling with the diffusers, being that it would be rags, solids, or anything, and it would be in need of cleaning. The reason for this lift-out mechanism is instead of draining the tank and washing this particular diffuser grid out, you can actually lift it with a crane, and you can wash it from the top surface of the tank and drop it back into the tank, which will be located back on the struts, and then the reconnection with your follower flange to the air main. So it gives you the versatility of taking one grid out at a time and cleaning it and putting it back in service. As I said in the classroom, the operational range per diffuser on this system is 5 CFM to 40 CFM per diffuser. And you will have to increase and decrease the airflows to the manifold itself depending on the treatment that you're doing in the grit removal, keeping everything suspended in the system. Does anybody have any questions about the equipment itself and how it's installed? Okay.
You said you had some winter applications. Do you have had applications where you're trying to take down the tank and you have it freezing because you can't drain totally?
Okay, the question was if the tank is taken down during the wintertime?
Right.
Okay. The question was, if the tank is taken down during the wintertime, is there a chance of the water freezing in the diffuser elements and not allowing you to do the proper cleaning on the system? The temperature that the manifold and header is as you drop down will not give it enough time for it to freeze. Basically, the diffusers are at the lowest elevation of the manifold itself, so it will basically drain right out. So this could be done 12 months out of the year. You could do any kind of maintenance on the system itself. Once again, as far as the application, the hose and clean the system would be, just a 1-inch fire hose, and basically hosing down any of the solids off of the header and stuff like all the diffuser elements itself. What we're trying to do is we're just trying to get those obstructions off the diffuser. So once again, we get that equal distribution throughout the channel itself. So it's consistently hydraulic in the tank and keeping the suspended solids floating in the tank. Do you have any more questions? Okay. That will conclude our on-site training with the fixed header removable course bubble system. Once again, as said in the classroom, any information can be found in the O&M that is going to be supplied to the city. It's got a step-by-step of any kind of procedure from fixing to storage to operational ranges, and I highly recommend, if there was a question on the system itself, was to refer back to the O&M. Thank you very much. Should have went to Hollywood, huh? Jeez.
You got a couple cards?
I'm going to drop some more off. I